Alright, in this video I'm going to be covering general solutions to trig equations and how to solve equations like this one. And I'm going to start you off in degrees, but I will cover radians as well. So let's say we want to solve this equation for theta in that range. Now I'm going to be using the techniques that I talked about in my video on trig equations with exact solutions. So you might want to watch that first. So what I'm going to do is draw the unit circle. Cos is the x-coordinate, so we want an x-coordinate of root 3 on 2, which is almost 1, it's like 0.9. So I'm going to go over here and draw that in, and then these are our two solutions. Now, if I'd drawn that circle a bit more accurately, you would easily see that this is at negative 30 degrees, and that one's at 30 degrees. So those are some possible angles. Now you might be thinking, isn't that outside of this range? But the angle that we're looking at here isn't theta. It's actually what's inside the brackets here, the 3 theta minus 60 degrees. And that's going to have quite a very different range from this. I'm going to show you two different methods to do this. Now the first method is quite straightforward, but not so elegant, I think. But I think you need to go through the first method in order to understand the second method properly. So what I'm going to do is, let's work out the range for 3 theta minus 60, because we want to find all the possible values for that. So what you can do is just sort of manipulate this in the same way that you would do things to both sides of an equation. So we might multiply each of these by 3. So we get 0, let's think of 3 theta less than that times 3 is 1080 degrees. And then we can subtract 60 from each one. So negative 60 less than or equal to 3 theta minus 60 less than 1020. So that gives us the range of the angles that we want. So negative 30 is in that range because it's bigger than negative 60. So that one's fine. There won't be anything smaller than that. So at negative 30, 30, but then we can actually go all the way up to 1020, so there's going to be more. We could have 360 minus 30. Let me just write that as that and not simplify that for the time being. Then we're going to have full revolution plus 30. So 360 plus 30. And then we can also have 2 full revolutions minus 30. So 2 by 360 minus 30 degrees. And then also 2 by 360 plus 30 degrees. And then I think you'll find if we go up to 3 by 360, we're going to be outside of that range. So let's just work out what all these are. We've got those, we've got 330 degrees, we've got, that one's 390. 720 minus 30 is 690 degrees, and then 720 plus 30 is 750. So now what we can do is just start solving this equation for theta. So we would first move the 60 degrees over the other side, so add 60 degrees to everything. So add 60 to that, add 60 to that, add 60 there, 450, 750, and that plus 60 is 810. And then we can divide everything by 3. So 10 degrees, 30, 130. That divided by 3 is 150. Then we've got 250 and 270. So those are all the solutions. That's method 1. Now let's see if we can find a more elegant way to do that. So instead of listing all of these out, what you can do is just say, so 3 theta minus 60 degrees. So it can be negative 30, but then you can add any multiple of 360 degrees to that to get another way of expressing this angle. So we can just say like negative 30 plus 360 degrees times some number, some whole number. And then you'll also have the positive 30. plus 360 degrees times some number. Now, if you're going to introduce a variable, you should say something about what it is. So you can write like for any integer n there. I'm just going to put that into like set notation shorthand. So I'm going to say n is a member of the integers. That's a z with a double line. We use that for integers because of the German word Zahlen for numbers. Okay, so we've got that. And then we can add 60 to both sides. So 30, if we add 60 to that. And 90. And then we can divide both sides by 3. So 10 degrees, that divided by 3 is 120. And then we've got 30 plus 120 degrees n. Now we can think about what values of n are going to give us a number in that range. So we could say n equals 0 will work. So that one would just be 10 degrees if n is 0. And that one's going to be 30. Depending on the range, you would also have to consider like n equals -1 and maybe -2 and so on. But that's as low as we can go. And then we could say, okay, if n equals 1, we're going to have 10 plus 120, so that's 130. And that one plus 120 is 150. Now, we could also have n equals 2, so 240 plus the 10, 250, and 240 plus the 30 is 270. Or you can just take the last pair that you got and add 120 onto them. So that plus 120 gives you that one, and that plus 120 gives you that one. So I think that that's a much more elegant solution, and it's often quicker, especially when you've got quite a large number there. Like if it was 2 theta, this one would probably be just as quick as that method. But if it's like 3 theta or 4 theta, it takes quite a while to list all these out and work all them out. So that way is often quicker. You can even, instead of writing that, you could have even said something like plus or minus 30 degrees plus 360 degrees times n. And then you can, add 60 to both sides, so you get 60 degrees plus or minus 30, and then divide everything by 3, so you've got 20 plus or minus 10 plus 120 degrees, and you can do it that way as well. All right, so that, I think, is the better method of doing that. And I'll go through how to do it in radians as well. I've just got the calculator out so that we don't have to do the fractions by hand, because I know a lot of people find that a bit annoying. So same question, just in radians instead of degrees. Now what I would do to start is write, so 3 theta minus pi on 3. We've got negative pi on 6 is one possible solution. And then we can add any whole number of full revolutions to that. So 2 pi is a full revolution. So that times some integer n. Or we can have the positive pi on 6 plus 2 pi n. And I'll just say n is a member of the integers. If you haven't studied set notation yet, don't worry about that. You can just write out, for any integer n or something like that. So now what we can do is add pi on 3 to both sides. And if you don't want to work out the fractions yourself, what you can do is just, so think of that as being negative 1 on 6, like just disregard the pi. So we've got negative 1 on 6, and then we want to add 1 on 3 to that. And that gives you that. Now, most calculators will have a button that will convert into a fraction for you, so 1 over 6. So, and then we just need to put the pi back in. So pi over 6 plus 2 pi n. And then we've also got like positive, see if I can get rid of that. So positive 1 over 6 plus 1 over 3, and then you can see that's a half, or you can use your fraction button. So pi over 2 plus 2 pi n, and then we can, that's 3 theta, and then we can divide both sides by 3. So we've got pi over 18 plus 2 pi over 3 n, and pi over 6 plus 2 pi over 3 times n. So then we can just start listing out the possible values in that range. Now, the smallest one is going to be, sorry, that's theta. The smallest one is going to be pi, just pi over 18, with n being 0. And then you'll have pi over 6. And then we'll have where n is 1. So we can do 1 over 18 plus 2 over 3. Just disregard the pi's and then convert that to a fraction. So 13 pi over 18. And then we'll have the same thing with the pi over 6. Although what you might like to do is just work out the next one after that by adding another 2/3 to that. So we'll just go plus 2/3. Just because we've already sort of typed that bit in. Alright, now let's do this one, 1 over 6 plus 2 over 3 gives us that. So 5 pi over 6, and then we'll have that plus another 2/3. For like when n equals 2, I'll just add another 2/3 of pi to that. And 3 pi over 2. So that's how you solve it in radians. Alright, let's try one with tan. So, we draw the unit circle. We've got tan of negative root 3, so on the line x equals 1, we go down to negative root 3, which is about 1.7, so just a bit below the bottom of the unit circle. And then you want to draw that through the origin. Not very good at drawing straight lines on this. Okay, so, and then you can just kind of like eyeball this. That's like negative 60. Now, we could have negative 60, so that's one solution. And then you can also add 180 to that to get the other one. So you'll have negative 60, plus 180, and then you can add another 180 to that to go around to another way of expressing this one. So negative 60 plus, that'll be plus 2 times 180. So instead of just writing all these out, why don't we say negative 60 plus some whole number of 180s. So negative 60 plus 180 degrees times n, where n is an integer. And then we can just solve this for theta, so we can add 20 degrees to both sides. 2 theta is negative 40 plus 180 degrees n. And then divide both sides by 2. So negative 20 plus 90 degrees times n. Now let's think about what values of n are going to give us a value in that range. So we can have n equals 0 and just have negative 20, but there might be one before that. So let's try n equals negative 1. So then you're going to get negative 20 minus 90. That's negative 110. If you try going back one, like subtracting 90 from that, you're going to be outside of that range. So that's the first one. And then we'll have, with n equals 0, you'll have negative 20. So, I mean, you can think of it as like trying n equals negative 1, 0, 1, 2, etc. Or you can just sort of think of adding 90 to the previous one. So, like that one plus 90, negative 20, add 90 again, you get 70. Add 90 again, you get 160. If we add another 90, we're going to be outside of that range. So those are all the solutions to that equation. And if they just asked for, you might get asked a question where they've given you a range, or you might be asked to find the general solution, in which case you would just leave it there. That would be the answer. All right, let's try sine of 4 theta plus 60 degrees equals negative root 3 on 2 for theta between 0 and 360. So I'm going to start by drawing the unit circle. Sine is the y coordinate, so we want to go down to y equals negative root 3 on 2, down here. Draw that in. And then there's our two angles that we're looking for. So we can start out by saying 4 theta plus 60 degrees could be negative 60. And then you can add any multiple of 360 to that to get other ways of expressing that angle. So 360 degrees times n. And then this one, we could call that negative 120. And then add any number of 4 revolutions to that. And then we just want to clarify that n is an integer. So now we can start solving this for theta. So we could subtract 60 from both sides. Negative 120. And minus 60 from that, we get negative 180. And then divide both sides by 4. So negative 30 plus 90. And that divided by 4 is negative 45. Alright, so now we can start working out what values of n are going to give us something in that range. Now what you can do is, because we're just going to have like negative 30 and then like adding some number of 90s on that, what I'm going to do on the calculator is just go negative 30 and then, so that's outside of the range, but let's add 90 onto that. So 60, that would be a possible value. And then let's just add 90 again to that by just pressing equals again, because that's going to add 90 onto the 60. So 150. Add 90 again, 240. Add 90 again, 330. If I add 90 again, that's going to go outside of the range. So that's all the ones for that. Now let's have a look at the negative 45. Oops, no, just negative 45. So that's outside the range, but let's add 90 onto that. So 45. Add 90 again, 135, add 90 again, 225, add 90 again, 315, and then that's going to be everything. So 405 is outside the range, so we can stop now. Okay, so that's how you solve that one in degrees. Alright, let's have a go at the same question, but in radians. So I would start off by saying the angle in there, that's going to equal, so that's negative pi on 3. That's a radians version of 60 degrees. And then we can have that plus any whole number of 4 revolutions to get different ways of expressing that angle. And then this one is negative 2 pi on 3, which is the radians version of 120 degrees. And then we can add any number of 4 revolutions to that. And then we just want to say where n is an integer. Now we could move the pi on 3 to the other side, so subtract that from both of them. If we subtract pi on 3 from that, you're going to get negative 2 pi on 3. You can do that with the calculator if you like, just go negative 1 on 3 minus 1 on 3 and then convert to a fraction. And that minus pi on 3 is going to make just negative pi. And then we can divide both sides by 4. So that's going to make negative pi on 6. Again, you can do that on the calculator if you like. You can go negative 2/3 divided by 4, and then just convert that to a fraction. So negative pi on 6. That divided by 4 is going to make pi on 2. We've got negative pi on 4 plus that divided by 4 is pi on 2. And then we can start working out values in that range. So let's just start with the negative 1 over 6. So that's not in the right range, but what we can do is add a pi on 2 to that. So add 1 on 2. And then let's convert that to a fraction. So we'll get pi on 3 will be one solution. And then let's just add half again. So I'll just hit equals again. And that will give us another one. So 5 pi over 6. And then we can just add another one and convert to a fraction. So 4 pi over 3. And then again, 11 pi over 6. And then you'll find if you add another half, we're going to be outside of that range. So that's bigger than 2 pi. So we don't want to have that one. Okay, and then we can try these. So negative 1 over 4. That's not in the right range, but let's add a half to that. Oops. So that gives us a quarter. So pi over 4. Let's add another half. 3 pi over 4. Add another half. 5 pi over 4. Add another half. And that is 7 pi over 4. And then if you add half again, we're going to be greater than 2. So that's outside the range. So that's all the solutions for radians. Now, if they ask you something like solve sine theta equals negative root 3 over 2 and give the general solution, so no range for theta, we want to give all possible solutions for theta, of which there are infinitely many. There is another way of thinking about this. So previously I just said negative 60 plus 360 degrees times n, or negative 120 plus 360 degrees times n. There is another way of expressing this, which your teacher or your exam or whatever might want you to use. So I thought I'd go over this. So let's just think of listing these out. I'm going to call the negative 120, I'm going to think of that as negative 180 plus 60. And then we've got the negative 60. And then you could have 180 plus 60. And then we could have 360 minus 60. Except I'm going to call the 360 2 times 180. And you'll see why in a minute. Now, we can also have like a full revolution plus another 180 plus 60. So that full revolution plus 180, I'm going to call that 3 times 180. So we've got that plus 60. All right, and so on. Now let's see if we can find a pattern in all of this. This one we could actually think of that as being like 0 180s minus 60. And this is negative 1 times 180. So we've got negative 1 times 180 plus 60, 0 180s minus 60, then 1 180 plus 60, 2 180s minus 60, 3 180s plus 60. So you've got an integer multiple of 180, and then either plus or minus 60, depending on whether n is odd or even. So we want to have like either plus or minus 60 there. Now let's think about how to express that. So there's actually a really neat way to express plus or minus depending on whether something is odd or even in mathematics, because think about negative 1 squared. You've got negative 1 times negative 1, so the two negatives cancel and make positive 1. Negative 1 cubed, though, is that times another negative 1, so that's just going to be negative 1. Negative 1 to the 4th is that times negative 1 again, so negatives cancel and that makes positive 1. So with the powers of negative 1, you get this pattern of alternating positive and negatives, just like we have here. So you can actually express that as n times 180 degrees plus negative 1 to the n times 60. Except now we actually want it to be negative when n is even. So we actually want that to be minus. So you can just sort of check, like if you're not sure whether that should be plus or minus, you can just check by trying a particular value of n. So if you go n is 0, which would give us this one, and negative 1 to the 0 is just 1. So that's correct with the negative there, because that gives us negative 60. So the general solutions for sine are sometimes expressed like this instead of like this. I mean, they're actually the same thing, but this one's just a little bit more elegant. So your teacher might want you to express it that way. Oh, and if you're working in radians, this would be, so 180 degrees in radians is pi, so it's pi n minus negative 1 to the n times, that's pi on 3. And, you know, that could be in whatever order. Like, you might be more used to writing it as negative 1 to the n times pi on 3 plus pi n or plus n pi. Doesn't matter. All the same thing. All right, let me just sum up all the general solutions. So for cos, your unit circle diagram will look something like this. And then you've got alpha, like whatever angle this is, depending on what cos theta equals. you're going to get, so that angle, or the negative version of that angle, so plus or minus alpha, plus a whole number of full revolutions, so 360 degrees times n if you're working in degrees, or if you're working in radians, you'll have plus or minus alpha plus 2 pi n. For sine, you're going to have whatever angle that is, that plus a whole number of, well, we'll do it in degrees first, plus a whole number of full revolutions, or the other one, which is going to be 180 degrees minus that first angle. So whatever that is, like, don't actually write it like that, but work out what 180 degrees minus alpha is. So that plus a whole number of full revolutions. So you might want to express it that way, or you can also express that sort of like wrapping up those two into one thing as -1 to the n times alpha plus a whole number of multiples of 180 degrees. So like when n is 0, that's just 1 times alpha plus 0, so that's just alpha. If n is 1, then you've got -1 times alpha, so negative alpha plus 1 times 180 degrees. So that's just 180 minus alpha, so that's that one. And then if n is 2, you get 360 plus alpha, and so on. So yeah, so you've got that one in radians. This will be alpha plus 2 pi n and pi minus alpha plus 2 pi n. And for this sort of simplified version, that's going to be -1 to the n times alpha plus pi n. You might want to memorize that just because it's not really immediately obvious, like that one is immediately obvious to me because you've got, the positive or negative angle plus some number of full revolutions, but that one I think is a bit more mysterious. So yeah, I would kind of memorize that one. Okay, and then for tan, you've got your angle alpha, and then you've also got that plus 180 degrees, and then you could do plus 180 degrees again, and so on. So you'll have your angle alpha plus some whole number of multiples of 180 degrees, or in radians, it's going to be alpha plus pi times n. So those are all the general solutions that you need to know. Now, so far I've been doing fairly simple trig equations where the hardest part was just the trig and there wasn't much algebra to do. But if you want me to do some harder ones where, there's coses and tans and cots everywhere and you have to do a bunch of algebraic manipulation and simplification before you actually get to the stage of solving the trig equation part, then leave me a comment below, and don't forget to give this video a thumbs up if you enjoyed it, and consider subscribing.